Hi everyone. So my partner Val couldn't make this talk. So I'm going to talk about what we work on during the privacy residency last month. We're working on a tools for Anon Communal Actions with ZK for vote privacy and TE for arbitrary threshold voting and registration flows. And we're going to talk about why we want to work on this, and how the system has been designed, and what we learned during implementing this, and what are the current status of the system. So if you're based in Taiwan, I think you guys will be familiar about that last year is a critical year of the workplace abuse situation in Taiwan. There's several, or I would say a lot, like workplace abuse incident report through public sector and also private company. Like there's a workplace abuse at Ministry of Labor, which is quite interesting. And there's also the workplace abuse at Delta Electronic, and there's a recent incident at Kubo AI that people might be familiar with locally. And there's also sexual abuse in McDonald's in Taiwan. So last year is a kind of shocking year to me that a lot of things happened, make me realize that there's not a communication way to talk about things that we want to talk about privately. So that got us interested and motivated into building this kind of solution for people. And during the privacy residency, we talked to several other residents throughout the month with privacy researcher, talk about the current reporting projects often lead to targeting on marginalized groups that people will get punished, get harassed for starting to talk about something publicly that might compromise other people's benefits. And we talked to Amazon labor organizers that the people who launches strikes on Amazon drivers will get punished. And we talked to labor advocate that the current tech problems really can build trust because they are not privacy enough to make everyone trust the system to report or vote on something. And so we have a lot of shared experience inside the privacy residency that people often are advocates, activists that do strikes, that unite people and fight against something. And these are usually the people that get punished and get picked on when something went down. So instead of surveillance, we want to focus on positive collective actions to have a way to aggregate people's thoughts and to act together on something, to have a group, to have a support network. So the key design idea, what we want to build is we want to have a solution that validated workers or other qualified people to join the system. And we want them to have the ability to vote privately. And then we want to aggregate all these signals, all these votes from them, and release the information once the threshold is met so that they can act together on this. And so the design that we go is that user has a cryptographically or socially verified registration flow. What I'm going to talk about, like what does it actually mean by cryptography and how do we verify? And then once they join the system, they will have using zero knowledge proof to vote on specific topic, and we'll collect all those votes privately together. And once the votes have a sufficient amount are met, we will release all the vote that we gather from the user. So some imagined use case that we talk during the residency is like Lyft driver strike, because currently there's not a union for Lyft driver. So they don't have a way to share information across each driver to understand what the working situation is like. So we want to provide a solution like this to them that they can collect and report things on how much fee or how much money they're going to make on each ride. And is that fair? Are they exploited from the Lyft company? And also bullying from bosses, I think that's kind of obvious. We all have times that we want to report something about our boss, and also the rent strike. Like currently, the housing market is monopolied by the landlord. We don't have a way to talk with each other, like privately, about what's the housing market is like, how much everyone is paying, because no one wants to report this, because once you report this, you often get picked on by the landlord and often got punished. So this is also a use case that we can use ZKTOS to provide the payment of the rent to the landlord, and we can collect that data privately together, and then have a aggregated information about how much everyone is paying. Are we being overcharged for the housing rental price? So that's a solution that the anonymous coordination platform can provide. And also, in general, we can collectively build a platform that migrate and protect data from the user. So this is how we built the system. We have 4-step or 4 component inside the system. The first one will be the identity, and then registration, coordination, and release. The identity part would be how we verify this user's identity, and then once we check that this person is allowed to join a certain group, we will register them into a certain group that they can use as a private or a pseudo-anonymous identity to act on something. Once we have that identity, we can let them submit a vote, a proof on something they want to provide opinion on, and then that's where the coordination part comes in. And after we collect all the information, a certain threshold is met, we're going to release the data together and signed by a trusted machine. About the identity part, now we're using ZK email to check that the person have a specific domain of email that's say a company. So once we verify he, she, they hold the specific email, then we can allow them to join the group to act on providing opinion on that company. And this identity solution can be further expanded to different options, cryptography actions, like using NFC chip. Like we came up with this idea because the Amazon driver, they don't really have an email at Amazon. They'll usually just use their badge. So we can use the chip inside their badge to sign something on the identity, to generate their anonymous identity to vote on something that they want to report inside Amazon. And further, we can, like the landlord case, we can use ZKTOS to generate a web proof about people transferring fund, transferring rental payment to specific account to verify they are putting money or paying money to the same landlord. And yeah, in general, other use cases that we can just abstract this from the user, that we can use any kind of public key, public identity, public string as the identity input into the group to generate the private identity. So after we collect that identity, we'll let the user register into the system. Now we're only using Merkle tree to check that the specific public key or the string identity inside the Merkle tree to verify that this person belongs into this group. If you're in the ZK space, you will be familiar with this, that it will be called semaphore. But I'll explain why we are only going with the Merkle tree solution. So yeah, so after the user register into the system, if the user have a public key, then they can use the public key as the identity generation. Otherwise, we'll use something called VOPRF, which is something created by Meta. What it does is that it can use a string or any low entropy information put into the system, And the system, the VOPRF, will add randomness to that string, to that input, and generate a key pair for the user, which then we can use to register into the system as the identity for the user privately. So that's an alternative, and which make the system easier, that people don't need to bring their own key into the system. But that's something we can do and expand it into more use cases in Web3 and in Ethereum. So yeah, that's basically what the registration part is doing. Then after we can prove that the user belongs to a certain group, we then can collect the vote, collect the signal. We call them attestation from the user in our TE system, that the user belong in the system and they want to vote privately on something. Either it is like voting on whether the user want to join a strike, or they are providing a abuse information evidence on specific person inside the company. So now we just abstract it into a hash of private key and message that we allow users just to sign a arbitrary message to report on certain things. It can be vote, it can be evidence, it can be any information in general. And that can be switched into a more advanced cryptography primitives called Plume, which is quite new. But we then can skip the part of using private key and can use like more general information to sign something. And after the vote has been submitted to TE, we will then collect the information, and then the TE now will receive the plain text of the vote itself so that it can sign in future. So there's a certain trust assumption here about the TE, because it does collect information from user. But that's what we believe in TE right now. So we let go of this assumption and keep the implementation this way. So the TE will collect the information from the user, and once a certain threshold is met, that's for, take an example that if 5 employees report on a same boss about a workplace abuse related incident, then the threshold can be set by anyone. So let's say 5 incidents. Then once 5 people report on the same person, the information itself will be aggregated into an anonymous array of information, like A abused me at some time, during what night, what happened. Like 5 different arbitrary message in an array will then be signed by TE and released onto the website or report to, I don't know, Ministry of Labor or to the HR department. It can be any solution, but the point is TE will sign it and verify it's been collected from this system, and the information will then be released. So the reason that we took so many steps of the system is that we want to create a layer of security, because all technical solution has its disadvantage, and it might be break sometime. So we want to add on different solution a bit to make it more secured in a whole system. So that's why we use TE as the first line of defense, to trust that the environment is safe and no one has the ability to touch it unless someone hold a gun and run into AWS server and try to get the key out. And then we use the anon proofs to prevent that. Once, if the TE is really compromised, we can still have a certain degree of anonymous to prevent that people submit the proof will get picked out or will be identified. And then, so every time the TE collect to the certain threshold and it released it, we will delete all the information from the TE of the specific report and then signed it and released it to make sure that once it's finished, no data will stay inside our system. And then finally, the last assumption will be the people that register into the system, either they provide their own public key or they use the VOPRF. as long as their public key and private key is not compromised, then they will have the ability to recover you and stay anonymous inside the system. So this is why we choose to go with this implementation, have a layer of security because of scalable, because TEE, we have been debate about whether we want to use MPC, although MPC is a mature technology, but we feel like TEE is simple. We can just abstract it as putting a server onto a trusted machine. So we don't have to take care of all the connection issue with the MPC while scaling. And if a MPC server is offline, how do we recover the data? We want to skip that discussion and just go with TE. And for the key issuance, we use VOPRF because it's easy to recover. As long as the input is the same, we can always recover the same key pair for the user. And the downsides of TE are minimized because the assumption would be people breaking into the AWS to hijack the machine. And we want to make it more expandable so that user can bring in any ID from them with either the badge or the company email or any general private public key pair, and they can register into the system. And we abstract the voting from not only abuse or vote for, vote against something, we abstract it into an arbitrary data field so that people can report on anything, decide on their use case. And it'll be easy to customize with any kind of identity can register into the system and report and vote on any arbitrary things. Okay, so that's what the whole system is about. And now I'm going to talk a bit about the stuff we learned, the difficulties that we face that we hope you can avoid in the future. The first thing is NOR. We use NOR inside the implementation this time. We use primarily the ZK email NOR package, and we're exploring the NOR JWT for better UX. Difficulties that we face is that we want to use semaphore and ZK regex this time because semaphore will be an easier solution to register into the group and to vote on something. And the ZK regex will be easier to parse the information inside the email. But they are both not supported in the current NOR library right now. So you'll either have to go with Circum to work this out. So, but from the ZK email team, these two libraries will be released in the next month or two. So it'll be pretty soon. And we have a debate over ZK email and ZK NOR JWT because we believe that JWT will have better experience. For people that don't know JWT is when you use the sign in with Google solution. Every time you use that, it will generate a JWT for you. JSON, sorry, I forgot the full name, but it's JSON something token. Then that token will be used as the session verifier that you have successfully logged in through a certain email. So that would be better UX because now we use ZK email. It's kind of complex because user will have to send an email to themselves and say that they want to join the anonymous coordination platform, and we verify the email message and verify who sent the email to who, and we verify that's from the same user. So it's kind of, the UX is not very good. So we want to change to NOR JWT, but NOR JWT doesn't have any test in it. So it would be a debate into you want to have a more mature solution or you want to have something that have better UX. So for the next step, this is what we have finished, what we have done right now. We finished the system design, we finished the email identity verification circuit that allow people to verify their email, and we finished the proof of voting. After they join the system, they join the Merkle tree, they can generate a vote on specific thing, and then our server will aggregate information. And now we're in the part of implementing the server with the VOPRF key generation. And once we're finished that, the next step will be moving this onto a TEE machine and having client-side proving to generate the email proof, have a interface, and allow user to join the system, and then switching to Plume so that people don't have to use the public-private key pair to generate to join the system, and then adding number of different solutions to register into the system with the NFC card and ZK-TOS that we just mentioned. Okay, yeah, so that's what we have done through the last month at the privacy residency. Thank you guys for being here. Any question? You have one?
Why didn't you get more done? Come on, Ryan.
What do you mean? What do you get more done?
Oh no, I'm there's nobody else around you. Is it easy to extend to like other messaging services? And like, why would I want to use this over something like Signal? Or is it just like the coordination effort of existing encrypted messages is not there?
Yeah, so I think an alternative will be having an anonymous solution where we verify the user identity to see if the user come from the same company and let them join the same group chat and talk about things. That would be an alternative. We have been discussing about that, but that will require more complicated reason because the current messaging or chatting app, they don't verify user from a specific, I don't know, company or from a specific team to verify their identity. They just let them join privately, but we can't really know who are they. But in this system, we want to know that people come from the same team or at least know the people's identity to verify that they are in the group that can talk about specific things, like they came from the same company, so they both know their boss, so they get to talk about that. That's what we want to do to verify the identity. And so the current chatting solution don't have that. And the solution to allow people to verify their identity and join a group chat, talk about something, will require something called FHE, because once they joined, let's say if we don't want to store anything, then we'll use the FHE to first to verify what they report. Let's say A report on his boss, B report on his boss, and we want to use FHE to match the similarity between those messages to verify that they are talking about the same thing. But FHE is pretty expensive, so that's why it can't be done right now. So the easiest solution would be verify identity and join a group chat and talk about it. But there's just simply no solution for that right now.
Would it be easier if you made an enterprise solution that the company could set up to make ZK proofs of the identity of the individual?
Oh yeah, the reason we started this is because there's a previous solution called Callisto, which is created by Dan Bonet. What they do is that they allow college students to report college or university campus sex abuse incident, and they collect it together and match the information and generate key pair to people that report on the same thing, and let them use that key pair to discuss, hey, do you want to report this? Do you want to bring this up? And then if they agree, the information of their report will then be presented to the lawyer. So that's something they've been working on. But the pain point of that is that it's hard to convince university to use that because either someone have to host this service, host this machine. That will be, I don't know, a bit trouble to find a group of people that know how to do this right with the good OPSEC and to do this securely inside the university. I think that's the first issue. And the second issue is that you still have to trust the university, and the university will have to import the student list into the system so that they can verify who has the permission to report. And they have to update that list, I don't know, quite often if someone join or leave the university. So I think that would be the two biggest difficulties. One is trusting the university, and second is the operation cost of running such system. So we want to make it just easy to deploy either on TE, to host it on a cloud service, and using ZK proofs so that it's permissionless. Everyone can just register with their college email, company email. Yeah.
Thank you.
Yeah. Okay, thank you guys. Let's go to a happy hour.